Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit, where we're going to be talking about area ratios with triangles in particular. To get started, quick review of a very basic fact. The area of a triangle is 1/2 times the base times the height, right? So if you know the base, you know the height, you can find the area of that triangle. Now, very simple fact, but still worth saying, and a preview of what's to come here. Two triangles then, if they have the same base and the same height, kind of regardless of how they look, they clearly have the same area. Because if you calculate the area, 1/2 base times height, you're going to get the same number. Doesn't mean the triangles are the same, but they definitely at least have the same area. Now, what we're going to be talking about today with our area ratios is what happens when you change one of the quantities. In particular here, we're going to be talking about what happens when you change the base. So, our big fact, right, if we have two triangles here that share the same height, so we have same height in two different triangles, right? Then the ratio of their areas is the same as the ratio of their bases. So we have these kind of two ratios that are then equal to each other. So ratio of areas is equal to the ratio of the bases. So we have this picture down here, right, where we have these two triangles, actually the full triangle, ABC, and then we have this kind of smaller triangle ABD. So the ratio of them is BD to BC. So the idea here, and I really like thinking about this a lot of the time, if we have a triangle, so we have our full triangle there, we can think about then what happens if it's shrunk, right? We shrink that triangle to get this smaller triangle, ABD, right here. And then the ratio of their areas only depends on BD and BC, only depends on their bases. And just to clarify one more time, that's because they both have the exact same height, right? Both triangles here, even though it's an obtuse triangle, the altitude height lies outside of ABD, they both share that same height in this case. So they share the same height. The ratio of their areas is this ratio of the two bases there. Let's take a look at a problem here. This shows the power of this idea, and you can really quickly actually come up with solutions to these problems using area ratios. So we have a triangle shown here that has area 15. So our full triangle ABC has area 15. And then we are given some information here about the different points and how we're dividing stuff up from there. So first of all, E and F are evenly spaced along AB. So that kind of tells us that we're dividing this into 3 equal pieces down there. G is the midpoint of CF. So that tells us that these two kind of line segments here are the same length. And we want to know the area of ACG. Now, a little bit of weirdness is happening here. We don't actually know the dimensions of ABC. We don't know any of the lengths, right? We don't know what its base is, what its height is. We just know its area. And right, this is where people sometimes get confused on this type of problem because they think of, okay, I have a triangle, I need to know some lengths to find the area of that triangle. But you actually don't in that case. Because we know enough information about the bases, about these different kind of portions of the triangle, we are okay. So the first triangle we want to look at here, we kind of have 2 steps in this case. The first step is going to be almost identical to the picture we just drew there before. right? So if we look at this picture, we have the full triangle ABC, right? Then we have this shrunken triangle ACF, right? So if we look at these areas here, we can find the area of triangle AEF. So let me say kind of not AEF, ACF here, right? Now, what is its area going to be? Well, it shares the same height, if we draw that height straight down, as the full triangle, and its base is 2/3, right? So this is going to be 2/3 of 15. So this is going to be equal to 10. So almost immediately here, we can look at this ratio. We take the full triangle, we shrink it by 1/3, and then we're left with 2/3 of the area. So that area is 10 in this case. Now, the next portion is a little bit fun and a little bit kind of, you get to do a little head tilting if you like. The trick for the next portion is noticing that base and height can really be drawn from any of the different sides. So in fact, if we draw a height down this way, so let's draw a height this way, and let's tilt our head sideways and look at the red triangle ACF, G is the midpoint. So what does that tell us then? That tells us then, well, okay, the full triangle, right, has an area of 10. And since we're splitting it on the midpoint, we have half and half. So actually then the area of triangle ACG, right, this area is going to be 1/2 of 10. And this is then going to be 5 in this case there. So once you get good at this stuff, this can be almost immediate. So we say, okay, we shrink it by a factor of 2/3, so it goes from 15 to 10, and then we kind of shrink it by half, and it goes to 5. And so we then have our answer here of the area of our triangle ACG is going to be 5 in this case. And it's really powerful here. We don't know any of the dimensions. In fact, our triangle doesn't need to look like this one here, right? As long as we start with the triangle with area 15, the same conclusion will be true. Okay, that's good for today's video then. So thank you everyone for watching this video. Check back each Thursday for a new math tidbit in 2021. Visit ziml.areteem.org for more practice problems. And if you want to catch up with any of our Thursday tidbits and videos, right, take a look at the links posted below there as well. Goodbye.